Hi everyone, welcome to this lecture. So in this lecture, we will learn about the sigmoid function when it is used as an activation function. So sigmoid is an important activation function, especially when it is used with the output layer of the neural network. So this is sigmoid function. This is the mathematical representation of the sigmoid function. This is the equation of the sigmoid function. And this is the visual representation of the sigmoid function. So we can see that the minimum value of the sigmoid function is 0. The maximum value of the sigmoid function is 1. Okay, if we pass 0 to the sigmoid function, it will give us the value which is equals to 0.5. It means the output of the sigmoid function is 0.5 if the input to the sigmoid function is 0. If we pass a large negative value to the sigmoid function, it will give us a 0 value. Similarly, if we pass a large positive value, we will get the output of the sigmoid function which is equals to 1. So the minimum value of the sigmoid function is 0 and the maximum value of the sigmoid function is 1. So it is used to suppress the input between the range of 0 and 1. So this is some mathematics which is involved with the sigmoid function. So this is the equation of the sigmoid function. If I put x is equals to 0 here, what will happen? When we put x is equals to 0, it will become exponent raised to power 0. And we know that anything raised to power 0 is equals to 1. So 1 plus 1 becomes 2. So we will get a value equals to half. It means if the input to the sigmoid function is 0, the output of a sigmoid function is 0.5. If we pass a very large negative value to the sigmoid function, which is here minus infinity, then if I put x is equals to minus infinity, then this minus and this minus will become plus, and I will get exponent raised to power plus infinity, which is equals to infinity. And if we add any number to the infinity, we will get infinity. And 1 divided by infinity is equals to 0. It means if we pass a large negative number to the sigmoid function, we will get 0. Similarly, if we pass a large positive number to the sigmoid function, if we put x is equals to plus infinity here, we will get minus infinity. Then exponent raised to power minus infinity will becomes 1 over exponent infinity. Anything raised to power infinity is infinity, and 1 over infinity is equals to 0. So it will become 1 over 1, which is equals to 1. So we can see that the minimum value of the sigmoid function is 0. The maximum value of the sigmoid function is 1. And if we pass 0 in the sigmoid function, we will get 0.5. So these are a few properties of the sigmoid function. The first property is it is not good for hidden layer when there are more than 2 layers in a neural network. That is, if we have more hidden layer in the neural network, it is not a good idea to use sigmoid as an activation function with the hidden layers. So in the next slide, we will see why it is not a good idea to use sigmoid function with the hidden layers. Its minimum value is 0 and maximum is 1. Therefore, it is good for classification layer. It gives us the classification probabilities of classes. So the minimum and maximum value of the probability is also 0 and 1 respectively. Similarly, the minimum and the maximum value of the sigmoid function is also 0 and 1. Therefore, a sigmoid function can be used with the classification layer or the output layer of a neural network. It can give us the classification probabilities of the classes. The third property is the sigmoid has the biased average. This means the average of its input is 0, but the average of its output is 0.5. Now, if I pass two values to this sigmoid function, the one value is minus 10 and the other value is plus 10. Okay, so the average of minus 10 and plus 10 is equals to 0. It means the input to the sigmoid function, the average value of the input to the sigmoid function is 0. But what we will get at the output? For minus 10, we will get 0, and for plus 10, we will get 1. And mean of 0 and 1 is 0.5. So this means that the output of the sigmoid function is biased and the input of the sigmoid function is not a bias. That is, the sigmoid function produce the biased average value of the output. So in that way, this is the reason that the sigmoid function is a non-linear function, because it maps the input function into a non-linear space. That is the reason that sigmoid function is a non-linear function. Now, why it cannot be used with the hidden layer? So this is the reason. if we see the visualization of the derivative of the sigmoid function, so the derivative of the sigmoid function is 0.25. This is the derivative of the sigmoid function, and this is the actual sigmoid function. If we see the derivative of the sigmoid function, its maximum value is 0.25. So what will happen? We know that the hidden layers are used for learning, that during back propagation, we will have the derivatives of the term. In the previous section, we got a gentle introduction of the back propagation. We will learn in detail about the back propagation in the coming sections of the course. But we know that in the back propagation, when we write the equation of the back propagation, we need gradients or derivative. So the derivative of the sigmoid function is 0.25. So if we need to multiply 0.25 more than one time, our value becomes close to 0. Here is the example. Here 0.25 is multiplied by 3 times. So its value is close to 0, that is 0.016. If we keep on multiplying 0.25 with each other, we will get a 0 value. So if we get a 0 value during the back propagation or during the learning of a neural network, our neural network will not learn, and that problem is called vanishing gradient problem. Now, the gradient are the derivatives which we use in order to write the back propagation equation. So in back propagation equation, we saw in the previous section where we learn about the basic of back propagation, that we have the gradient equation like dE by dy, dy by dH1, or dE by dW1. So that derivatives are multiplied with each other. And if we use sigmoid as an activation function, the derivative of the sigmoid will become a very small quantity. And if we keep on multiply these small quantity, we will get 0 during the back propagation, which is one of the most important stage of the learning of neural network. So if we use sigmoid function with the hidden layer, then we will face a problem which is known as vanishing gradient problem. That is, our gradient will die out during the back propagation. And if our gradient die out during the back propagation, there will be no learning in the neural network, and the performance of neural network become worse. So that is the problem with the sigmoid function, due to which we do not use sigmoid function with the hidden layer. We use sigmoid function as an activation function only with the output layer, so that we can perform classification. So in this lecture, we learn about the sigmoid function. We learn why sigmoid function is useful activation function when used with the output layer of neural network, and what are the problems of using sigmoid as an activation function with the hidden layer. So I hope you understood this lecture. Thanks for listening, and I will see you in the next lecture.